Usually when we talk about a medical diagnosis, there is a very comforting expectation of precision.
Right, it feels very clinical.
Yeah, it feels like engineering. I mean, if you break your arm, the x-ray shows that jagged white line, and the doctor just points at the screen and says, well, there it is. That is the problem.
It is entirely binary. I mean, the bone is broken or it isn't. You cast it and it heals.
Exactly. It's clean. But then you look at human aging, and suddenly that precision just completely vanishes.
Oh, absolutely. We don't treat it like a broken bone at all.
Right. We just sort of accept that our bodies inevitably break down like it's a natural law of the universe. But what if that assumption is completely wrong?
Which is a huge question to ask.
It is. I
Right.
mean, what if the first human being who will live to be 1,000 years old is already alive today?
Yeah.
And not just like a baby being born right now in a hospital. What if that person is currently walking around in their 50s or 60s?
I mean, it sounds like the premise of a science fiction novel.
It really does sound like a movie pitch, but this isn't, it's not fiction. That is a genuine, heavily debated claim made on international television back in 2008 by the subject of today's deep dive.
Aubrey de Grey.
Exactly. He is a British biomedical gerontologist, which essentially means his entire focus is studying the biology of aging to develop actual, tangible medical interventions.
And that audacious claim is exactly why his life and work are so fascinating to unpack for you today.
Right. Our mission today is to trace this incredible and, frankly, unorthodox narrative arc.
We are looking at a man who started out in computer science, pivoted entirely into biology, challenged the very foundations of how the scientific establishment views aging.
Accidentally solved a 60-year-old riddle in advanced mathematics along the way.
Yeah, that part is wild. And then, faced significant professional controversies later in his career.
I think the best way to wrap our heads around his whole approach to the human body is to use an analogy.
Okay, let's hear it.
Imagine treating the human body like a piece of legacy software. If you have a computer program that has been running continuously for decades, it naturally accumulates bugs. Tiny errors in the code just build up over time.
Sure, the system gets bogged down.
Exactly. But if you can identify those specific accumulated bugs, which in the human body would be cellular and metabolic damage, you can theoretically write a patch to fix them.
You don't need to rewrite the entire operating system.
Right. You just need to patch the bugs faster than they accumulate.
And, that software analogy is actually the perfect lens for understanding his entire worldview.
Because he started as a software guy, right?
Exactly. Aubrey de Grey wasn't supposed to be a biologist at all.
Oh, not even close.
To understand how someone wakes up and decides to, quote-unquote, cure aging, you really have to look at how his brain was wired from the very beginning.
So take us back. Where did he start?
Well, he was born in London in 1963
Mm-hmm.
and raised by a single mother who was an artist. But interestingly, she didn't push him toward the arts at all. She actually aggressively encouraged him in the subjects where she felt she lacked the most confidence herself.
So mathematics and science.
Right. And it clearly worked because he ended up at Cambridge, graduating in 1985.
Yeah.
But his degree was in computer science.
Yeah, his early career was entirely focused on artificial intelligence and software engineering.
Specifically, he was working on automated formal program verification.
Which is, in the most basic terms, designing systems that hunt down and eliminate bugs in incredibly complex code.
He was literally trained to look at massive, messy systems and find the microscopic mechanical failures.
So his brain is basically optimized for debugging legacy software.
Exactly.
But, how does a software verification guy end up trying to hack human mortality?
It actually comes down to a classic Cambridge graduate party.
Naturally.
Right. He attends this party and meets Adelaide Carpenter, who was a highly respected fruit fly geneticist.
Oh.
They hit it off, eventually marrying in 1991. But this relationship became the major catalyst for his professional pivot.
How so?
Well, her laboratory needed someone who understood both complex computer databases and biological data to manage a massive genetic database for fruit flies.
Oh, I've read about this. It was a project called Flybase, right?
Yes, Flybase. And he takes on that project, managing it for over a decade.
So you have this brilliant software engineer who is suddenly just completely immersed in the daily world of academic biology.
Yeah, he's surrounded by biologists reading their papers, having dinner with them.
And during this time, he has this massive realization. He notices that biologists were dedicating their entire lives to studying the mechanisms of aging.
But almost none of them were actively trying to stop it.
Exactly, they were just cataloging the decline.
They were observing the deterioration of the body with incredible precision, but they viewed it as a natural, inevitable process.
I have to play devil's advocate here, though. I mean, isn't there a massive level of hubris involved in that?
What do you mean?
You have a software guy wandering into a completely different scientific discipline, looking around, and just deciding that every single PhD in the room is missing the big picture.
Oh, it's incredibly audacious. Absolutely.
Yeah.
But if we look at the history of scientific breakthroughs, that outsider perspective is often exactly what is required to disrupt a stagnant field.
Because he didn't have that traditional bias.
Right. Because he wasn't indoctrinated in traditional biological fatalism, he simply didn't view aging as an unstoppable force of nature.
His brain just saw a system accumulating bugs.
Exactly. He looked at aging and saw a mechanical failure, a buildup of metabolic side effects. And in engineering, if something is a mechanical failure, it can theoretically be engineered away.
So he decides to just brute force his way into the discipline.
Yeah, he goes through this intense period of self-education, basically devouring biology journals and textbooks.
With his wife acting as an unofficial tutor,
Yeah.
right?
Yes. But, you know, if you were going to stand up in front of the world and claim you can engineer immortality, you can't just be the computer guy who reads a lot.
Right, you need actual credentials. People need a reason to listen to you.
Precisely. And in 2000, Cambridge awarded him a PhD in biology.
Wait, he just tested into a PhD. How does that work?
It was a PhD by publication, which is a rare but totally legitimate academic route in the UK.
Oh, okay.
The degree was awarded based on a book he wrote in 1999, focusing on mitochondrial aging.
Okay, let's unpack that for a second, because mitochondria are basically the power plants inside our cells, right?
Exactly. They generate the energy our cells need to function.
But the process of generating that energy is pretty messy.
Very messy. It produces toxic byproducts, like free radicals, which over time damage the mitochondria's own DNA.
So it is exactly like a power plant slowly poisoning itself with its own exhaust.
That's a great way to put it. De Grey's book detailed how this specific microscopic breakdown contributes to the macro-level aging of the human body.
So the power plants are accumulating bugs.
Right.
And by 2005, he takes all this self-taught biology and his systems engineering mindset, and he codifies it into a master framework.
The SENS framework.
Right. Strategies for engineered negligible senescence.
Which is a mouthful.
It really is.
Yeah.
But negligible senescence basically just means not aging.
Right. And the core argument of the SENS framework was revolutionary because of its pragmatism.
How so?
He argued that we didn't need to completely understand every single mysterious mechanism of human metabolism to stop aging.
Because metabolism is just too complex, right?
Exactly. It's wildly complex. Instead, he argued, we just need to fix the damage it leaves behind.
Right. He basically created a punch list. He broke down all the cellular damage into 7 specific categories.
Things like cell loss, which you could theoretically fix by injecting stem cells.
Or the accumulation of junk inside the cells, which the body doesn't know how to break down.
And that specific problem, the accumulation of intracellular junk, leads to one of his most brilliant and, frankly, eccentric experiments.
Oh, you're talking about xenocatabolism. I love this part of the story.
Yes. So the human body accumulates this stubbornly indestructible cellular garbage over time.
Right.
Specifically, it's a substance called lipofuscin. Our cells just can't digest it, so it builds up over decades and contributes to cellular dysfunction.
And a traditional biologist might spend 20 years looking at the human genome, trying to find a way to make our own cells process it.
Exactly. And where does de Grey look?
A graveyard.
A graveyard.
Wait, like a literal cemetery. He went to a graveyard to cure cellular aging.
He did. I mean, it is a remarkable leap of logic.
Walk us through his thinking there.
He reasoned that if human remains do not permanently accumulate in the soil over thousands of years.
Because obviously the Earth isn't just covered in perfectly preserved bodies.
Right. So something in the natural environment must be eating them.
Wow.
There must be microbes in the soil that possess the specific enzymes capable of breaking down every single human biological waste product.
No matter how stubborn.
Exactly. Including lipofuscin.
So he is literally looking for the ultimate biological recycling plant in the dirt.
And he found it He tested soil from a graveyard, found specific bacteria, extracted them, and proved that they could indeed digest this indestructible human cellular garbage.
That is just incredible. Going back to our analogy, he basically realized our legacy software couldn't clear its own cache, so he went out and found a third-party software patch in the dirt that could do it for us.
That's exactly what he did.
And if we could just safely install those microbial enzymes into human cells, the cells could finally clean themselves.
It perfectly highlights his pattern of synthesizing completely disparate concepts, looking at macro-environmental decay to solve microcellular aging.
But, all of this engineering takes a massive amount of time.
It does.
And that brings us to his most famous concept, longevity escape velocity.
Right, also known as the Methuselarity.
Methuselarity, yeah. Explain how that works.
Okay, so imagine a scenario where you don't need a magical pill that instantly grants you 1,000 years of life all at once.
Because that's what people usually picture when they hear this stuff.
Right, but that's not it. You only need a medical therapy that repairs enough cellular damage to buy you, say, 30 extra years of healthy life.
Okay, so I get a patch that keeps my software running for 3 more decades.
Exactly. And while you are living those extra 30 years, medical technology doesn't just stop.
Right, science keeps moving.
It continues to advance exponentially. By the time you reach the end of that 30-year extension, science has progressed enough to give you another 50 years.
And then 100.
Exactly. You eventually reach a velocity where life-extending therapies are improving faster than your body is aging.
You escape the gravitational pull of mortality.
That's longevity, escape velocity.
But to get the funding to develop those therapies in the first place, he argued that society had to wake up from what he called the pro-aging trance.
Yes.
Which is this idea that humanity has this massive psychological defense mechanism where we just romanticize aging.
We call it the circle of life.
Right, because historically we couldn't do anything about it, so we had to make peace with it.
And he views that fatalistic acceptance as the single biggest hurdle to actually getting the billions of dollars in funding needed to cure it.
And speaking of funding, radical theories claiming we can live to be 1,000 require astronomical amounts of money.
Oh, absolutely.
Plus, they have to survive the brutal gauntlet of scientific peer review.
Which is never easy for an outsider.
So how did the actual biological establishment react to a computer scientist telling them he was going to cure death?
With intense skepticism and, in some cases, outright hostility.
I can imagine.
But de Grey understood how to incentivize behavior. In 2003, he co-founded the Methuselah Foundation.
Okay.
To get mainstream scientists to actually care about his framework, they launched the Methuselah Mouse Prize.
Which was a cash prize.
Yes, the goal was to financially reward researchers who could significantly extend the lifespan of a mouse. It was a very clever way to fund the actual groundwork required to prove his theories.
But that friction with the establishment really peaked in 2005, right?
It did. The MIT Technology Review hosted an official debate.
And they offered a prize for this, too.
They did. A $20,000 prize to any molecular biologist who could prove that de Grey's SENS framework was, quote, so wrong that it is unworthy of learned debate.
Wow. That is an incredibly high bar for a scientific challenge.
It really is. And the judges were heavyweights, too.
Like who?
Well, it included people like Craig Venter, who was one of the first people to sequence the human genome.
Oh, wow. Okay, so a stalemate in science usually means the establishment wins, though.
Right.
I mean, if you can't definitively prove your radical theory, you don't get the massive grants. So did this debate completely bankrupt his momentum? What was the actual verdict?
The results were highly nuanced. The judges ultimately decided that none of the challengers successfully proved de Grey wrong.
Okay, so he won.
Not exactly. They also firmly stated that de Grey hadn't made a compelling case for his ideas either. They concluded that many of his proposals just couldn't be verified with the technology that existed in 2005.
So it ended in a scientific stalemate.
Exactly. Not demonstrably true, but not demonstrably false.
But the pushback just kept coming. Later that same year, 28 scientists published an article in MBO reports basically stating that none of de Grey's hypotheses had ever actually extended the life of any organism.
Let alone a human being.
Right.
And to be fair, even de Grey's own organization, the SENS Research Foundation, which he co-founded in 2009, admitted that at that moment you could not reverse aging. The technology just wasn't there yet.
But he never wavered.
No, never.
And he actually put his own money on the line to prove it. In 2012, de Grey inherited over $16 million.
Which is a life-changing amount of money.
Right. Most people would buy an island or just retire. But he immediately turns around and donates $13 million of it directly to the SCNS Research Foundation to fund the research.
He essentially bankrolled his own paradigm shift.
It really represents the ultimate tension between the visionary and the pragmatic.
How do you mean?
Well, the scientific establishment demands rigorous, slow, incremental proof. But de Grey demanded a moonshot engineering project.
And he was willing to pay for it.
Exactly. But this ability to look at a highly complex biological system and see a solvable network problem didn't just disrupt biology.
No, it didn't.
In 2018, that exact same brute force computational mindset accidentally solved a 60-year-old riddle in advanced mathematics.
The Hedwiger-Nelson problem.
Yes. I love this part. This is such a staggering flex of raw intellect.
It really is.
The puzzle is in a field called geometric graph theory, and it was proposed back in 1950.
Can you break that down for us without getting too bogged down in the deep math?
I'll try. So it essentially asks this. If you have a flat, infinite plane.
Like an endless sheet of paper.
Right, and you connect a bunch of points on it that are exactly 1 unit apart, how many different colors do you need to color all the points so that no two connected points are ever the same color?
Okay. And for over 60 years, the greatest minds in mathematics knew the answer was somewhere between 4 and 7.
Exactly. But no human mathematician could move the needle to prove exactly what the lower bound was.
Until the anti-aging biologist decides to play around with it in his spare time.
Right, because he approached it not as a traditional mathematician, but as a software engineer.
He didn't try to solve it with elegant chalkboard equations.
No, he used sheer computational processing power.
He utilized polymath projects and brute force computer algorithms.
Right, to explicitly construct a massive graph with over 1,500 vertices. And that massive complex graph definitively proved that you absolutely need at least 5 colors.
Which increased the known lower bound for the first time in 6 decades.
Just incredible. He sees patterns where others see noise.
He approaches a mathematical plane the exact same way he approaches a cellular network.
But as is so often the case with these highly public, outsized visionary figures, the story takes a very sharp turn here.
It does.
We have to address the professional downfall that occurred just a few years later.
Yes, we do. In August of 2021, the narrative surrounding him shifted significantly.
What happened?
2 women came forward with allegations of sexual harassment against de Grey.
Okay.
Given his high-profile role as the chief science officer and really the main public face of the SCNS Research Foundation, he was immediately placed on administrative leave while an independent investigation was conducted.
I mean, when someone's entire life's work is tied up in a single foundation they helped build, an investigation like that is going to have massive ripple effects.
Oh, absolutely.
So what did the independent report actually find? Let's stick to the facts here.
The investigators' report was very specific. It concluded that while various other allegations against him were not substantiated by the evidence, de Grey did indeed make inappropriate remarks to the 2 complainants.
Okay.
Furthermore, the investigator determined that de Grey had attempted to communicate with one of the women through a third party during the probe.
Which is a major issue when an active investigation is happening. You can't do that.
Exactly. It constituted interference with the investigation, although de Grey claimed he thought that specific fee in the inquiry was already over.
So the foundation was forced to make a decision about their most famous founder.
They were, and they made it. They permanently removed him from his position.
Wow.
In a subsequent statement in 2022, SCNS clarified their position, affirming that while his actions showed poor judgment and boundary-crossing behavior, they explicitly stated he was not a, quote, sexual predator.
But the fallout from that kind of leadership crisis is never just contained to the individual, is it?
No, it heavily impacted the foundation itself.
How so?
Several major donors actually sued the SCNS Research Foundation for fraud.
Wait, really? For fraud?
Yes. They alleged that the board knew they were going to remove de Grey, but intentionally hid that fact while still accepting massive donations based on his name and reputation.
Wow, that is messy.
It was eventually settled out of court. And as a direct result of being ousted from his own foundation, de Grey started an entirely new organization in 2022 called the LEV Foundation.
LEV, as in longevity escape velocity.
Right. And that new foundation focuses heavily on robust mouse rejuvenation.
It perfectly illustrates how fragile the ecosystem of radical science really is.
It really does.
The science behind longevity escape velocity doesn't change because of the personal conduct of the person who proposed it. The math is still the math.
Right.
but the social capital and the deep public trust required to secure millions of dollars in funding, that can just vanish overnight.
It forces us to separate the validity of the idea from the flawed humanity of the individual who champions it.
So, stepping back from the controversies for a moment and looking at the overarching narrative of his life, what is the actual legacy here?
Well, whether Aubrey de Grey ends up being right or wrong about the exact timeline of when humanity hits that escape velocity, you have to admit his impact is undeniable.
Definitely. He single-handedly forced the global scientific establishment and really the general public to debate aging in a completely new way.
He undeniably changed the paradigm. Before him, the conversation was entirely about managing decline.
Right.
He forced the world to look at aging not as an inevitable tragedy, but as a solvable engineering problem.
And he remains entirely committed to seeing that future realized.
He really does.
I mean, he has even signed up with Alcor to have his body cryogenically preserved when he dies, just in case the software patches aren't ready in time for his natural lifespan.
Covering all his bases.
Exactly. But, he also has this much broader view of the future that I find incredibly thought-provoking, especially when you think about the societal implications of living that long.
You're referring to the intersection of longevity and automation.
Exactly. De Grey has publicly argued that artificial intelligence and automation are inevitably going to take over the vast majority of human jobs in the near future.
Which is a very common prediction right now.
Right. But because of that economic shift, he believes that a universal basic income is going to be an absolute necessity for society to function.
So if we connect this to the bigger picture, you aren't just looking at living a really long time in the world as we know it today.
No.
You are looking at living a very long time in a completely different societal structure.
And that is the final thought we want to leave you with today. Imagine a scenario where De Grey is absolutely right.
Okay.
Imagine the legacy software of your body gets the ultimate touch. You achieve longevity escape velocity, and you are going to live to be 1,000 years old.
But you are living those 1,000 years in a post-scarcity world, right? Robots and artificial intelligence are doing all the manual and analytical labor. You receive a universal basic income.
The fundamental human struggle for survival, the need to just grind out 40 hours a week to pay for shelter and food, is essentially solved.
Suddenly, you are looking down the barrel of centuries of free time.
Imagine being 400 years old and looking back at a 50-year career you had in your hundreds. Like it was just a brief summer job you had in high school.
It's hard to even fathom.
You could master 10 different instruments, live in 50 different countries, outlive entire political systems.
The problem shifts entirely. It is no longer about the hardware or the software crashing.
Right.
It's about figuring out what you actually want to use the computer for.
It stops being a biological engineering problem and becomes an existential one.
True.
If you have 1,000 years stretching out ahead of you and absolutely no economic requirement to work, what exactly would you do with your centuries?
A lot to think about.
Thanks for joining us on this deep dive. See you next time.